In this module, we will examine the air conditioning and pressurization system of the ATR. We'll first start out with a brief system description. Next, we will look at the air conditioning packs, the air ventilation system, and the pressurization system. Finally, we will review the controls and indicators associated with each system, as well as some limitations. The air conditioning system consists of two packs located in the main landing gear fairings. The job of the packs is to provide conditioned air to the cabin for comfort and pressurization. These packs operate independently of each other. The operation of the packs is completely automatic. An external air ground cart can be plugged into a connector located on the right side of the aircraft. This cart supplies conditioned air directly into the aircraft. The packs process bleed air from the pneumatic system and convert it into cool air, which is circulated through the aircraft via a system of ducts. The left pack normally supplies the flight deck. The right pack normally supplies conditioned air to the cabin. In the event of a failure of either pack, the remaining pack will supply both compartments. After the pack valve, bleed air is conditioned by the ACM, or air cycle machine. There is one ACM on each side of the aircraft. The purpose of the ACM is to adjust the air to the proper temperature for the cabin and flight deck. This air then flows into a mixing chamber located under the floor of the aircraft. The mixing chamber mixes ambient cabin air with air from the packs. The mixed air is then ducted to the proper zone. Conditioned air is distributed to the cabin from the mixing chamber through overhead ducts which route the air to individually controlled eyeball vents. Air from the cabin is evacuated through guides located along the floor of the left cabin side. From there, part of the air is recirculated through the cabin via fans. The remainder of the air is exhausted overboard through outflow valves located on the underside of the aft fuselage. The lavatory is ventilated through a vent line. Airflow is generated by cabin differential pressure. Cabin pressurization is maintained by modulating two outflow valves between the open and closed position. Cabin pressurization is maintained by constricting the amount of air that is exhausted overboard. The outflow valves are located on the bottom side of the aft fuselage. The controls and indicators for the air conditioning system are located on the overhead panel. The pressurization system is controlled by a control panel located on the flight instruments panel. Pressurization system information is displayed on the flight instruments panel as well. Each air conditioning pack processes pneumatic air supplied by the left and right sides respectively. Pneumatic air flows through the bleed valves down to a pack valve on each side. This valve is electrically controlled and pneumatically operated. In other words, pneumatic air pressure is required in order for the pack valve to open. The pack valve is a butterfly type valve. The purpose of the pack valve is to shut down the pack when required and to maintain a constant pressure of air supplied to the pack. Both pack valves require DC power from the DC essential bus in order to work. In the absence of electrical power, the pack valve will automatically close. The pack valve has two modes of operation. These modes are the normal flow and the high flow modes. The mode of a pack is determined by the position of the flow push button on the compartment temperature panel. When the flow push button is released out, both pack valves will deliver a constant 22 psi of pressure to the packs. When the flow push button is pressed in, both pack valves will deliver 30 psi of pressure to the packs. The high caption in the push button illuminates blue. The increase in air pressure available to the packs will increase the flow of conditioned air produced by the packs. In other words, more airflow coming in will mean more airflow going out. After the when the button is pressed in, after the pack valve, hot pneumatic air flows through a primary heat exchanger located in a ram air duct. This duct is located in the landing gear fairing. The scoop for the ram air duct is located at the front of the landing gear fairing. Air flows through the ram air duct, over the heat exchanger, and is exhausted overboard. This exhaust is located on the bottom of the landing gear fairing, just forward of the landing gear. In the event there is insufficient airflow for the heat exchanger, a ground turbofan will draw air from the ground inlet and blow the air over the heat exchanger. The inlet for the fan is the same ram air inlet the heat exchanger uses. Air is then exhausted overboard using the same exhaust as the ram air duct uses. This ground cooling fan is powered by pneumatic air through a turbofan shutoff valve. The turbo cooling fan is powered by an impeller which taps bleed air downstream of the pack valve, but before it reaches the heat exchangers. This air is controlled by a shutoff valve. The turbofan shutoff valve automatically opens anytime the airspeed is less than or equal to 150 knots and the landing gear is extended or retracted for less than 10 minutes. Therefore, the turbofans will operate for 10 minutes after gear retraction provided the airspeed is less than or equal to 150 knots. The turbofan shutoff valve is closed anytime the airspeed is greater than 150 knots, as this produces sufficient airflow over the heat exchanger. If an engine is experiencing low oil pressure, the turbofan valve on the opposite side will automatically open, and the associated turbofan will run at all times as long as the airspeed is less than or equal to 150 knots. This will occur regardless of the position of the landing gear. If the turbofan valve is not in the commanded position, The associated pack valve will automatically close to protect the pack against any damage. After the primary heat exchanger, the cooled pneumatic air will flow to a compressor. The compressor section increases the pressure and temperature of the partially cool bleed air. This compressed air then flows to the secondary heat exchanger for additional heat extraction. The secondary heat exchanger is also located in the ram air duct. It uses the same airflow as the primary heat exchanger for cooling. The air that flows from the second stage heat exchanger is used to power the turbine, which originally compressed the air the first time through. Upon reaching the turbine section, the hot compressed air undergoes a rapid expansion, which decreases its temperature dramatically. Airflow into the turbine is controlled by the turbine inlet control valve. The cold bleed air produced by the turbine then flows to a condenser. This condenser extracts moisture from the air exhausted from the turbine section of the pack. The dry air from the condenser then flows to a mixing chamber. The condenser uses the cooled compressor air that flows through the secondary heat exchanger. This air flows through the condenser and then flows through a water extractor which removes moisture from this air. From there, the air flows through an expansion turbine which rapidly cools the air. The air from the expansion turbine is then mixed with bleed air to add heat as required by the temperature controller. Temperature control is achieved by mixing bleed air with air produced by the expansion turbine. This bleed air is tapped just downstream of the pack valve. The amount of bleed air used is controlled by the temperature control valve. The position of this valve is set either by the electronic controller or directly by the compartment temperature selector knob on the air conditioning panel. This panel is located on the flight deck overhead panel. The operation of the air conditioning system is controlled by the temperature selector push button. The automatic mode is selected when the push button is pressed in. In this mode, the electronic temperature controller will control the position of the temperature control valve based on the temperature selected by the associated compartment temperature selector, as well as the temperature in the pack supply duct, aircraft skin temperature, and associated compartment ambient temperature. When the temperature selector push button is released out, the temperature control system for that pack is achieved manually. The position of the temperature control valve is then controlled directly by the associated compartment temperature selection knob. When manual is selected, the manual caption will illuminate in the push button. Click on the left temperature selector push button to continue. In the manual mode of operation, A temperature sensor in the associated pack duct will limit the duct temperature to 88 degrees Celsius. If this temperature is reached or exceeded, a limiter will gradually close the temperature control valve so as to allow more cold air into the duct. Regardless of the mode of operation, if the duct temperature exceeds 92 degrees Celsius, the overheat caption will illuminate in the associated temperature selector push button. In addition, a single chime will sound, both master caution lights will flash, and the air light illuminates on the crew alerting panel. If the temperature out of the compressor section of the pack exceeds 204 degrees Celsius, the pack valve will automatically close and a CCAS caution will be triggered, a single chime will sound, both master caution lights will flash, the air light will illuminate on the crew alerting panel, and the fault light will illuminate in the associated pack valve push button. An external air cart can supply conditioned air directly into the mixing chamber. This external air is plugged in through a connector located on the right side of the aircraft at the front of the fairing. Once plugged in, the external air cart will supply conditioned air to both mixing chambers. The mixing chamber mixes the air produced by the air conditioning pack with air drawn from the cabin. There is one mixing chamber per pack. The two packs are interconnected so that in the event of a failure of one pack, the remaining pack would be able to supply both the cabin and the flight deck. This cabin air is drawn by a recirculation fan. From the mixing chamber, the air is distributed throughout the aircraft. The output of the left pack goes mainly to the flight deck, whereas the output from the right pack goes mainly to the cabin. Any excess air from the left pack is used to supply the cabin. Two recirculation fans draw air from the cabin and mixes it with the pack air in the mixing chamber. This arrangement reduces the load on the packs. The recirculation fans are located in the underfloor area just ahead of the wheel wells. By drawing air through the floor vents, they can circulate air through the cabin while keeping the floor temperature comfortable. What is not circulated by the fans is discharged overboard through the outflow valves. The fans are controlled by two recirculation fan push buttons located on the compartment temperature panel. The recirculation fans are powered by the associated DC utility bus. In the event of an overload on the DC portion of the electrical system, the DC utility buses will be shed and the associated recirculation fan will cease to operate. The recirculation fans are controlled by two recirculation fan push buttons located on the compartment temperature control panel. When a push button is pressed in, the associated fan is operating. The fan rotation speed depends on the position of the associated temperature control valve. The rotation speed varies between 1500 and 2200 RPM. The recirculation fans will automatically run at full speed in the event the temperature at the floor level of the cabin is less than 18 degrees Celsius. In the event the fan speed is less than 900 RPM, or if the associated electric motor overheats, the fault caption will illuminate in the associated recirculation fan push button. In addition, a single chime will sound, both master caution lights will flash, and the air light illuminates on the crew alerting panel. The flight deck, forward cargo compartment, and the electric and electronic equipment racks are ventilated using ambient air. This air is then recirculated to the pressurized compartment or exhausted overboard. The direction of the air is controlled by two valves, the underfloor valve and the overboard valve. A separate ventilation system is used to cool the flight instruments, floor-mounted batteries, and electronics racks behind the pilot seats. Air is drawn forward through the flight deck and into this ducting by an extract fan. Aft of the fan, the air is then dumped out of the overboard valve. In this way, airflow from the flight deck is used to cool the flight instruments. The fan operates at one of two speeds depending on the flight deck temperature. If the temperature is below 20 degrees Celsius, the fan will operate at low speed. If the flight deck temperature is above 52 degrees Celsius, the fan will operate at full speed. The fan speed will vary proportionally with the flight deck temperature if it is between these two values. An extract airflow lever is located on the right maintenance panel. This lever closes the extract airflow valve in order to stop air from flowing forward through the flight deck in the event smoke has been detected in the forward cargo compartment. During engine start, the extract fan will stop for 120 seconds to avoid pressure shocks through the aircraft. When the fan shuts down, the fault light in the exhaust mode push button will illuminate. Two valves direct the air drawn by the extract fan to either the underfloor of the aircraft or overboard. These valves are the overboard valve and the underfloor valve. The operation of the overboard valve is controlled by the overboard valve control switch located on the avionics vent panel. This panel is located on the overhead section of the flight deck. The overboard valve allows air to be discharged overboard. The overboard valve controls the operation of the underfloor valve. Due to this, the overboard valve switch should be in the auto position to allow the proper operation of the underfloor valve. If the overboard valve is in the auto position, the position of the overboard valve is a function of the exhaust mode push button and whether the aircraft is on the ground or in flight. If the exhaust mode push button is pressed in, the overboard valve will be fully open and the underfloor valve will be fully closed if the aircraft is on the ground and engine 1 has low oil pressure or is not running. In this situation, the extract fan will run continuously. The pressed in position of the exhaust mode push button is the normal position for this push button. If the aircraft is on the ground with the number 1 engine running, or if the aircraft is in flight, the extract fan will run continuously. The overboard valve is fully closed and the underfloor valve is fully open. Pressurization of the aircraft is achieved by controlling the amount of air that is exhausted overboard. The cabin and flight deck are pressurized through both the left and right packs. This inflow of air to the cabin is fairly constant throughout the range of power settings. Two outflow valves are used to control cabin pressurization and cabin rate of change. One outflow valve is an electro-pneumatic valve, and the other is a pneumatic valve. The outflow valves are located on the bottom of the aft portion of the fuselage, just forward of the aft entry door. A vacuum entry port is installed in each valve and provides the vacuum pressure to operate the valve. A torque motor along with the metering valve controls how far each valve is allowed to open. The pressurization system can operate either in the automatic mode of operation or in the manual mode of operation. In the automatic mode, the pneumatic valve is slaved to the electro-pneumatic valve by an interconnected vacuum tube which allows both valves to operate simultaneously. The outflow valve provides positive and negative pressure protection. Each outflow valve incorporates a manometric capsule which will open the outflow valve in the event the cabin pressure differential exceeds 6.35 psi. In the event the cabin pressure differential exceeds a negative 0.5 psi value, a non-return line will also open the outflow valve to relieve the negative pressure differential. Pressurization is normally controlled by an electronic digital controller located on the center flight instruments panel. The digital controller calculates a reference cabin altitude for the existing flight altitude. The electronic digital computer then uses a torque motor to position the electro-pneumatic outflow valve so as to maintain the calculated cabin altitude. The pressurization controller is powered by DC bus 1. The pressurization controller takes into account the departure field elevation, the destination field elevation, the existing cabin altitude, and the aircraft's flight altitude to calculate the required cabin elevation. The pressurization controller uses information from ADC-1 to determine the aircraft's altitude. The altimeter setting on the captain's altimeter will be used for calculations. If ADC-1 should fail, the pressurization controller will use ADC-2 for that calculation. However, a barometric setting of 29.92 inches will be used. So if ADC-1 is lost, the crew will need to enter the pressure altitude of the landing airport into the landing elevation window of the controller. The electro-pneumatic valve requires electrical power in order to operate. Loss of power or loss of signal from the pressurization controller will cause the electro-pneumatic valve to close automatically. The electro-pneumatic outflow valve is powered by the DC emergency bus. The pressurization system is placed in the automatic mode when the mode selector push button on the cabin pressurization panel is in the pressed in position. This is the normal position for this push button. In order to operate in the automatic mode of operation, the manual rate knob must be in the normal position. The manual mode of operation is selected by releasing out the mode push button. When selected, the manual caption illuminates in the push button. In addition, the digits in the landing elevation window will extinguish and the electro-pneumatic outflow valve closes. Once in the manual mode, the manual rate knob is used to directly control the pneumatic outflow valve. The manual rate knob can select any rate of cabin change from -1500 to +2500 feet per minute. Prior to placing the system in manual, you should set the manual rate knob to the 9 to 10 o'clock position. In this position, there will be no signal to increase nor decrease the cabin altitude, therefore no pressure bump will be experienced when transitioning from auto mode to manual. In order to understand how the automatic pressurization works, we'll go through a sample flight. During the pre-flight, the crew will set the landing field elevation on the pressurization control panel. The landing field elevation is set using the Elevation Set toggle switch. This toggle switch is spring-loaded to the center position. The selected landing field elevation is displayed in the digital landing elevation window. The plus position of the toggle switch increases the landing field elevation, and the minus position decreases the value. A landing field elevation between minus 1,500 and plus 9,900 feet can be selected. Elevations can only be selected in 100-foot increments. Let's assume takeoff from an airport with a field elevation of 20 feet above mean sea level. The destination field elevation is 900 feet. The flight plan calls for a cruise altitude of 20,000 feet. Click on the Elevation Set toggle switch to continue. Next, make sure that the manual rate knob is in the normal position. Click on the manual rate knob to place it in the normal position. The automatic pressurization system gets a signal from a landing gear microswitch which determines how much the torque motor moves to apply vacuum pressure to the outflow valves after takeoff. The system then maintains the cabin altitude of the takeoff airport up to 3,500 feet, which we'll look at more closely in a minute. During the climb, the pressure controller will maintain a proportional pressure differential between the cabin altitude and the aircraft's altitude. The cabin pressure controller will climb the cabin altitude at a maximum rate of 550 feet per minute. The pressurization system will maintain a maximum cabin differential pressure of 6 psi. If the aircraft is at flight level 250, the cabin altitude will be at 6,740 feet. When the aircraft starts to descend towards the destination airport, the pressurization controller will start to descend the cabin at a maximum rate of 400 feet per minute. For the landing, the pressurization controller will target a cabin altitude that is equal to the landing field elevation that was set during the pre-flight, minus 300 feet. After touchdown, the cabin pressurization controller will then open the outflow valves so as to increase the cabin altitude to the landing field elevation that was set during the pre-flight. During this depressurization phase, the cabin pressurization controller will use a maximum climb rate of 550 feet per minute. Once the cabin altitude is equal to the landing field elevation, the outflow valves will be fully open. In the event you need to return to the departure airport after takeoff, the pressurization controller will instead use the departure airfield elevation minus 300 feet as the target cabin altitude for landing. This is called the automatic return feature. This feature is available up until the time the aircraft climbs 3,500 feet above the departure field elevation. At that point, the cabin pressurization controller will use the landing field elevation that was set during the pre-flight. The maximum rate of descent can be changed by pressing the descent rate push button on the auto pressurization control panel. When this push button is pressed in, the cabin pressurization controller will use a maximum descent rate of 500 feet per minute. You should note that this push button has no effect on the maximum climb rate. The normal position for this push button is the released out position. The pressurization system can be placed in the manual mode of operation by placing the mode selector push button to the released out position. This will disable the automatic pressurization controller and the electro-pneumatic outflow valve will close. The manual caption will illuminate when the system is in the manual mode. Click on the Mode Selector push button to continue. The manual rate knob is used to manually control the pneumatic outflow valve. Using this method, the cabin rate of change can be changed from minus 1,500 feet per minute to plus 2,500 feet per minute. The crew would be responsible for maintaining the correct cabin altitude. The pack valve push button controls the operation of the associated pack valve. In the pressed in position, the associated pack valve will open provided electrical power and pneumatic pressure is available. The right pack valve will open after a 6-second delay for passenger comfort. In the released out position, the associated pack valve is closed and the off caption illuminates. The fault caption illuminates in the event the associated pack valve position disagrees with the commanded position, or if there is an overheat downstream of the pack compressor. In the event of an overheat, the pack valve will be latched closed. In the event the fault caption illuminates, you will also get a single chime, both master caution lights will flash, and the air caption will illuminate on the crew alerting panel. The flow push button controls the amount of pressure that is regulated by the pack valves. In the released out position, both pack valves will regulate pressure to 22 psi. In the pressed in position, the flow push button will cause both pack valves to regulate pneumatic air pressure into the packs to 30 psi. The increase in pressure results in an increase of flow out of the pack. The high caption illuminates in the push button when the high position is selected. Two indicators show the temperature in the selected compartment and the associated duct outlet. The selection of which zone is measured is made by the compartment toggle switch. The switch allows the crew to check the zone temperature and the duct temperature for the flight deck or the passenger compartment. The Temperature Select push button controls the mode of operation of the pack. In the pressed in position, the associated pack is operating in the automatic mode and the desired temperature is selected by the compartment temperature selector. In this mode, the electronic temperature controller maintains the desired compartment temperature. In this mode, the associated duct temperature will be limited to 88 degrees Celsius. When the push button is released out, the compartment temperature selector directly controls the temperature control valve of the associated pack. The manual caption illuminates in the push button. In this mode, the associated duct outlet temperature is also limited to 88 degrees Celsius. The overheat caption illuminates in the event the associated duct temperature exceeds 92 degrees Celsius. In addition, a single chime will sound, both master caution lights will flash, and the amber air light illuminates on the crew alerting panel. The recirculation push buttons control the operation of the associated recirculation fan. When a push button is pressed in, the associated recirculation fan will operate. The fan speed is then dependent on the position of the temperature control valve. In the released out position, the associated recirculation fan is off and the off caption illuminates in the push button. In the event a recirculation fan overheats or it has low RPM, the fault caption will illuminate in the push button. This will be accompanied by a single chime and both master caution lights will flash, and the air light illuminates on the crew alerting panel. The overboard valve switch controls the operation of the overboard valve of the avionics vent system. In the auto position, the avionics vent system will operate automatically. In this mode, the position of the overboard valve is dictated by the exhaust mode push button selection and the phase of flight. In the full closed position, the overboard valve will be fully closed. Placing the switch to the full open position will open the overboard valve. You should not open the overboard valve if the differential pressure exceeds 1 psi. Opening of the overboard valve while in flight will result in a depressurization of the cabin as well as a possible collapse of the overboard duct. The exhaust mode push button controls the operation of the exhaust system, provided the overboard valve switch is in the auto position. The pressed in position of this push button is the normal position. In the pressed in position, the operation of the extract fan and the position of the overboard valve and the underfloor valve depend on whether the aircraft is on the ground or in flight. If the aircraft is on the ground and there is low oil pressure on the number 1 engine, the extract fan will run continuously. The overboard valve will be fully open, and the underfloor valve will be fully closed. If the aircraft is in flight or the aircraft is on the ground with the number 1 engine running and the overboard toggle switch in the auto position, the extract fan will run continuously, but the overboard valve will be fully closed and the underfloor valve will be fully open. Placing the exhaust mode push button to the released out position will turn off the extract fan. In flight, the overboard valve will be partially open so as to allow differential pressure to provide the necessary suction to provide cooling airflow in the compartments, and the underfloor valve will be closed. This mode would be used in the event the extract fan overheated or were running at too low an RPM. In this mode, the overboard caption will be illuminated in the push button. If the exhaust mode push button is released out when the aircraft is on the ground with a ground power unit powering the aircraft, a ground mechanic call will be triggered and the horn will sound continuously. Since the fan will be turned off, there will be no airflow through the compartments, and this will result in an overheat condition. If you recall, the extract fan will stop for 120 seconds during engine start. In this case, the fault light will illuminate, but the ground mechanic horn will not sound. The fault caption illuminates in the event of a failure of the extract fan or there is a fan overheat. The fan overheat threshold is 90 degrees Celsius. If the fault caption illuminates, you will also hear a single chime. In addition, both master caution lights will flash and the air light on the crew alerting panel will illuminate. The fault light illuminates in the event the overboard valve is not in the commanded position. On the ground with low oil pressure on engine 1, the fault light will illuminate if the overboard valve is not in the full open position. The fault light will not illuminate if the overboard valve switch is in the full close position. You should not confuse this fault light with the fault light in the exhaust mode push button. If the aircraft is on the ground with engine 1 running, or if the aircraft is in flight, the fault light will illuminate in the event the overboard valve is fully open if the overboard valve switch is not in the full open position. Regardless of the reason for the illumination of the fault light, the light will extinguish in the event the overboard valve goes to the commanded position. Illumination of the fault light will result in a single chime, both master caution lights will flash, and the air light will illuminate on the crew alerting panel. The pressurization mode selector push button selects the mode of operation of the pressurization system. In the pressed in position, the pressurization system will operate in the automatic mode, and cabin pressurization is controlled by the electronic controller. Placing the mode selector in the released out position will select the manual mode of operation. The manual rate knob should be placed in the 9 to 10 o'clock position prior to switching back and forth between the automatic and manual mode. In the manual mode, the manual caption will be illuminated in the push button. The fault light illuminates in the event of a failure of the digital pressurization controller. In addition, a single chime will sound, both master caution lights will flash, and the air light illuminates on the crew alerting panel. The ditch position closes both outflow valves regardless of the mode of operation of the pressurization system. This is used in the event the aircraft is ditched in water and prevents water from entering the fuselage. The ditch mode is selected when the push button is pressed in. When selected, the on caption illuminates in the push button. In the ditch mode, two electric motors maintain both outflow valves in the closed position. There is one motor for each outflow valve. The motors used by the ditch mode are powered by the DC emergency bus. When both outflow valves are in the ditch position, the centralized crew alerting system will be activated. This will result in a single chime, both master caution lights will flash, and the air light illuminates on the crew alerting panel. The guarded dump push button is used to dump the cabin pressure. In the released out position, the digital pressurization controller will operate normally. When the dump push button is pressed in, the digital pressurization controller will be disabled and an electrical signal will fully open the electro-pneumatic valve. In turn, this will cause the pneumatic outflow valve to fully open as well, and the cabin pressure will be dumped. When in the dump position, the on caption illuminates in the push button. The dump mode is only available in the automatic mode. The test button electrically tests the pressurization system. The indications of a successful test are the numbers 18,800 and minus 8,800 alternating in the landing elevation window. In addition, the fault caption illuminates in the pressurization mode push button. It should be noted that the test function of the pressurization system is inhibited when the aircraft is in flight. Cabin altitude rate of change, and cabin pressure differential are displayed on the cabin pressure indicator panel. This panel is powered by the DC emergency bus. A red off flag appears in the top right-hand corner of the indicator in the event there is a loss of power to the pressurization indicator. The maximum differential pressure is 6.35 psi. The outflow valves will open if this differential limit is exceeded, and the cabin altitude will climb to relieve the pressure. If the cabin altitude exceeds 10,000 feet, both master warning lights will flash and you will hear a continuous repetitive chime. In addition, the excess altitude light will illuminate on the crew alerting panel. The maximum negative differential pressure is minus 0.5 psi. The maximum differential pressure for landing is 0.35 psi. The maximum operating altitude with one bleed system operative is 20,000 feet. This concludes the air conditioning and pressurization module.